Hi friends, today I am going to show you how to analyze a notch problem with Ansys Apdl. This is not Apdl product launcher, and we will give some file name as some file 3 and run. This is Ansys 12.1 version, and my laptop is Dell 3520 with i3 configuration and 6 GB RAM, and we have already given the name. It is better to clear and start every time, and job name we have already assigned. That's it. Preference, structures, next pre-processing, add element type, add, and we will be using solid 8 node 183 generally in fracture mechanics, and material properties we need to go. And this is a 2D analysis, so no need to take off thickness, everything. This is a plane stress or plane strain problem we are considering. In my case, material properties, structural, linear, elastic, isotropic, and Young's modulus as 1 maybe, and this is some 0.25. Next is we'll be doing the modeling, create key points in active CS. We'll be doing for 60 degrees angle. Okay, this is 0.4 is the notch length, and 0.4 is notch length, and width is 1 mm. This is based on my problem, it may be different, and this value, how we can calculate this notch point by as this is a 60 degrees, so we need to multiply 30 tan, that is tan 30 into 0.4. copy. If you have this already, it is very simple, but I don't have that right now, so it's very difficult. Next is for something I'm giving. Next is 0.8 apply. Next is 1 apply. Next is this is 0.8, and this is 0. Okay, it's completed. Next we will be drawing the lines. Before creating lines, we need to do one thing. We have to create a arc in which stress concentration area will be getting, and select this and give some radius. This as the notch length is 0.4, we need to give this as some 0.45. okay, and this element, as it is 60 degrees and this is half the model, we should give it as 1 as the full is 180, 150. Next. Okay, and we also will create another small thing like which has a very small radius of curvature, like 0.41. okay, in the same fashion we will be creating 150. Next thing we need to do is plot lines, and next what we will be doing is object. We will go to add these two lines. We will show you how to do that. This two as single, next this two as single, another. Now if you go and do multi-plot, see this is like this, and next we will be creating the other lines, straight lines, and this and this, this and this, this and this, this and this. That's it. Lines is completed. Next we will be creating the areas by lines. Sorry, oops, we need to zoom. Apply. Next, apply. Apply. Okay, so everything is created. Now modeling is finished, and the meshing is the more important thing, for which we'll be using the mesh tools. You just drag this, and this is very important tool. Every time it goes side, so it is better to decrease this diameter, this side line, so that we can use this easily. Okay, here can next we need to go and plot lines. Next, go to size controls, meshing, size controls, concentrate key points, create. This is a notch, so no need of quarter point element, but as the radius of this one is 0.01, we'll be giving 0.0005 for no distortion of element, and this ratio as 0.5, so that by multiplying both we will get as 0.01. And number of elements, it depends. In my case now I am giving as some 12. This is a coarse mesh, I would say, and this is not quarter point. If you are quarter point cracked, then 1/4 we will be giving. Here it is not so, 1/2 point. Next is we have we need to, how many elements we have given? 12. So we need to cut this also into 12 divisions. Apply, and this one also into 12. Okay, next first we will be creating this one. Next we will see what is the mapped mesh quadrilateral. You select, and you select this area and stop. Cannot be meshed with quadrilateral. Oh, why cannot we? Oh, sorry, we cannot do mapped mesh in the near concentrated cracked tip. We need to select this as free, and you do this. So you can see this is very nice mesh. Next, in the same fashion, plot lines. You zoom this area. Next, we already divided this into 12, and next this into 12. Next, what we need to do is we need to select this, and we will divide them into some 10, and we will give some spacing ratio as 7. What is the importance of spacing ratio is that the line division of lines will be thicker at one end, and it will become very small at other end, like I will show you. In this case, see that the element length is thick here, and it is very small here. Here you can see that it is not fine here, and it is small here, and but so we can change that by clicking flip. Okay, it will flip automatically. Next, we already divided this 12 into this 12, so we can do mapped mesh and quadrilateral by selecting this. See, now a very good fine mesh with concentric rings we got. Next is we will see we need to mesh the remaining area also. We have divided up to here. Next, what we can do is we will create a mapped mesh such that mapped mesh is only possible with four sides, so we will concatenate these things as single. First we will divide this as there are 12 lines, there should also be 12. We will divide this in such a form. This should be 7, this should be 3, no, this should be 6, 4, 2. That's right. No need of spacing ratio. Apply. Next, this 4 and this 2. We have divided. Next, we will be creating some concentrating rings. You will come to know what is it after creating this. See, and we'll be creating number of divisions like 10. Okay, we'll go 10, and spacing ratio some 8, or as the length is more we'll give more 8. Okay, we need to flip this one again. Okay, that's it, it's completed. Next, how to mesh is you need to concatenate this side. As I said, that mapped mesh is not possible with these many sides, so you need to concatenate this line, and this line, and it will make like a single line for the present meshing. Next, you select coordinator and mapped mesh, and mesh you select and click mesh, and you can see a fine nice. You can even decrease this spacing ratio increase or decrease. Based on that it will come. As it is a coarse mesh, it's okay with as of now. And you can delete. Once you have created, you can delete, so that addition of all the elements will be gone. But meshing is already is fixed. Next what we will do is we will divide this line into two. One, for point 8, 1 2 3 4 5 6 are there. For this is point 2, how many? 0.8 by 0.2 by 1 by 4 into 6. Okay, we will divide roughly this one into 2. Okay, 2. And next we have already, we can mesh this one. See, next we need to mesh this area. For meshing this area we need to divide this and this. We will divide this thing into some how much shall we divide? As this is point 4, I think something 4 are there, so we'll divide into some 6 or 6. Okay, 6 is fine, I think. If it is we can change it later. If okay, 7, let it be 7, no problem. We have divided these sides, but this is for mapped meshing. There are 1 2 3 4 5 sides, but maximum we can do is 4, so we need to concatenate these two lines. But we can do by selecting these two lines. Okay, next these are concatenated now. 1 2 3 4. We can do mapped mesh, quadrilateral mapped mesh, and select this and see this. But you can see that this is this is changed. This is due to that due to that the size of this one and this one is varying. So we can even by adjusting this lens and this shifting this line to side little bit, we can adjust straight. As of now this is mesh, I think. And another important thing is we will be doing is generally you can mesh option you can do and take 4 straight, but in my case I have not considered. You can consider, I think, if it is required. Next is applying load. Go to solutions, define loads, apply structural displacement. As this is a symmetric model, symmetry on line, there are so many lines like this, like this, like this. Okay, see, you can see now this is symmetry. Next is we will be applying pressure on this line, that is -1 in my case. Just okay. Next is we will be solving this. Okay, solution is done. That's it. Now whatever you want, you can just read from last set, and you can view the results or deformation plot results, counter or deformed shape, deform and undeformed shapes. See how it is. Next, counter plot of nodal solutions like stress or displacement sigma y. We will see it is as it is singularity is more here, it's infinity. You can see that it has increased a lot. And compare, it also depends on how many elements we have given. You can see this clearly. That's it. Thank you for watching.